All right, welcome everybody. So we're going to go ahead and talk about circles in this section. Okay, one of our conic sections, and we'll talk about the rest of the conic sections later in chapter 7. All right, so a circle, the technical definition, is the set of all points in a plane that are equidistant from a fixed point called the center. So if you have some fixed point and you look at all of the points that are equidistant, right? So let's say, that's the distance that we want all these points to be away. Well, if we just continue that same distance, right? We write down every single point that's that distance from the center, then eventually we will end up with our circle, right? Okay. And that fixed distance is, of course, called the radius. We know this would be r, the radius, okay? So remember, the radius goes halfway through a circle. It's the diameter that goes all the way through a circle. Then right here in the middle of the screen, is our equation for the standard form of a circle. When it's in this form, we can easily see the center HK and the radius R. Whatever these are, I'll just change their sign. So it's minus H, which means over here it's going to be a positive H. It's minus K, which means over here it'll be a positive K. That's going to be my center. And this last number, whatever it is, we'll just take the square root of it to find out what the radius is, okay? All right. So let's go ahead and kind of derive that formula really quickly. And then we'll go ahead and do this particular example. Okay, so let me go ahead and derivation of the equation of a circle. All right, now this derivation relies heavily on kind of what we talked about last time, that distance formula, that Pythagorean theorem, right? So let me go ahead, get a quadrant 1. It's just easiest to wrap our brains around quadrant 1 because everything's positive here, okay? All right, so let's say that we have a center of our circle, and we are going to call that center, this will be H, and this will be K. So the ordered pair will be H, comma, K for the center, okay? All right, then let's go ahead and get a circle. It's going to be centered around that point, okay? Now I'm going to pick some random point on the circle. Let's just say I pick this one right here. And we're going to call that one just x comma y. I don't have to subscript it like I did in the previous section because I don't have 2 points labeled with x's and y's. This is going to be the only point, so no need to subscript, okay? So we'll just call it generic x and y, okay? Now, we know that any of these x's, xy's, I picked this particular point, but I could have picked this xy, right? I could have picked this xy. That any of these xy's are always going to be r away from the center. So I'm going to go ahead and draw a segment that we'll label as r. All right, so let me go ahead and put an r in here, you guys. All right. Now, if we use the Pythagorean theorem, now how can I use the Pythagorean theorem? I would need a right triangle, right? So if I drop a right triangle or make a right triangle out of these 2 points, I mean, that's not technically right, but you guys get it. Okay. Then I just need to label again the side lengths, right? So if I go in here and I label those side lengths kind of like we did last time, so let me draw this a little bit larger. Okay. We know this is r long because that length is this length, right? But we just need to figure out what the 2 legs are. Well, the 2 legs, if you come here and you use what we did last time, this bottom leg is as long as this segment is on the x-axis. And we said last time to figure out how long it is from here to here, you take the further along number minus the earlier number, right? The bigger number minus the smaller number. Okay, so this is going to be x minus h long. So I'm going to record that over here. And similarly, along the y-axis, if I want to figure out how long this leg of the triangle is, I just need to figure out how long that segment on the y-axis is. And that one would be y minus k long. So if we went in here and we did the Pythagorean theorem for this, right? So remember the Pythagorean theorem is a squared plus b squared, okay? Then our A could be like our X minus H. Doesn't matter if you use the other leg, but just to match with the formula, I'll pick that leg. And then Y minus K would be the vertical leg. And C would be the hypotenuse, which in this case is R. And this is the equation for a circle, right? That we just saw on the last slide. Okay. So once we have something in that form, right, then it's really easy to go either way, to be given the center and the radius and to put it into an equation. When I put this -3 in, it has to become a +3. When I put this 2 in, it has to become a -2. And then since the right-hand side of the formula is r squared, then I need to take the radius and square it. So 4 squared is 16. So there is our equation for this particular circle. So let's go ahead and do some problems, okay? So this is that kind of written out, okay? So let me just kind of go through some problems with you guys, okay? All right, write an equation of the circle in standard form and graph the circle. Okay, so let's start off by graphing it. We're going to go to 0, -3, and that's going to be our center. So that would be right here. And our radius is 2. So that means that we're going to have to go 2 away. I always say northeast, southwest. So I'm going to go 2 up and put a dot, 2 to the north, 2 east and put a dot, 2 south and put a dot, and 2 west. And then we have our circle. Don't mind my drawings of circles, you guys. I'm not one of those people that can do that. All right. So that is us graphing it. Now we have to put it into the circle formula. X minus h squared plus y minus k squared equals r squared. Now, the h, k, right? The h and k are right here. Now, if 0 is what I'm putting in for the h, then it will just be x squared. There won't be anything behind it because the h is 0, right? Okay, so it's kind of like thinking of basically just saying this part's gone, the h is gone, okay? All right, and then when we substitute in the k, the -3, well, when I put it into the equation, I told you it's going to become a +3, but let's make sure everybody understands why. Technically, there's a y minus from the formula, right? And then you're also putting in a negative, but we know that minus minus, right, or minus a negative actually becomes a plus. So moral of the story, you guys, just always change the sign when you're plugging it in. And then over here, we have 2 squared. So if we clean this all up, we got x squared plus y plus 3 squared equals 4. And that's going to be the equation of our circle in standard form. Let's try another here. All right, so we're going to go to 4, 3. Should be right there, right? And then we're going to go for a radius of 3. So up 3, to the right 3, down 3, to the left 3. So now we can draw our circle. All right. So let's go ahead and use our formula. X minus h squared, y minus k squared equals r squared. There's my h, there's my k. So if we put 4 in, it's going to be -4. Always change its sign. If we put 3 in, it's going to be -3. And then we'll put 3 in for the r. So this will be x minus 4 squared plus y minus 3 squared equals 9. I feel like these are so easy. These are like my favorite things, circles are. All right, same deal, graph, write the equation. All right, so they're only giving us the information that 3, 2 is where the center of the circle is. That's all they're giving us, okay? So in our formula, we already know that it's going to be x minus 3, because we're changing the sign on the +3. And if it's a -2, then here it will be a +2. All right, now we need to put the radius in, but we don't technically know the radius right now, right? So we need to draw this circle so that it is tangent to the y-axis. Tangent means that the circle just like nicks it. It doesn't cross over it. It just touches it in one spot. It doesn't go through it, in other words. So this wouldn't be allowed because it touches it twice and it goes through it. We just want to nick it at one spot. That's what tangent's going to be, okay? It intersects it one time. So let's try to draw that, okay? So if we were to draw that, and I'll probably be best if I use a legit circle and not my drawn circles, right? Okay, so if we want to do that, oh, I don't know what just happened. Let me try that again. Okay. Oh man, sorry guys, technical difficulties. All right, so if we want to draw that, oh yeah, sorry, it's so awkward for me because this is different than when I do it on the board. Maybe I will just draw it, you guys. Okay, if I want to be tangent to the y, right, then my circle will have to look something like this. All right, good enough, okay? You'll notice that it only touches the y-axis one time. It didn't say tangent to the x, so it's okay that it crosses through the x-axis in 2 spots, right? But it has to be tangent to the y. Now, why did I need to draw that circle? Well, I need to find what the radius is, right? And so now I can clearly see my radius right here. So it looks like it's going to be 3 squares long, right? So that's going to be our r. So we'll substitute 3 in to the equation here. So the final standard form would be that. Okay. So actually not too bad. It's mostly done by drawing, not a ton of algebra there. Just make sure you draw a nice, good picture. Make sure you have graph paper. All right. Now they want us to take this, the standard form equation and write it in the general form. Okay, so that's nothing new for you guys. This is all just algebra you've been doing all class, okay? So let's go ahead and just FOIL out the x plus 8. And then we'll FOIL out the y minus 1. We know we got to do x times 8. And then we got to do 8 times x and 8 times 8. 8 times x and 8 times 8, which is 64. And we'll do the same thing with the y's, right? Y times y and y times -1. And then -1 times y and -1 times -1. Negative times a negative is a positive. All right, we're going to go ahead and combine like terms. So we have x squared. When we combine the 8x with the 8x, we get 16x. And then when we combine the -1y and the -1y, we get -2y. And I'm going to glance up at this general form, you guys, just so I know what the goal is, okay? So x and y need to be near each other. Ooh, we need an equals 0 on the right-hand side. Okay. All right. So there's still some more combining that I might do. Let me see here. I got my x squared plus 16x. You know what? Let's just do this. Let's go ahead and start to write it a little bit in this form up here. So the x and the y squareds are next to each other. So this guy over here, we're just going to move him a little bit closer to the x squared, okay? Then after that, it says ax. So I'm going to put this 16x next. Then it says by. So I'm going to put this -2y next. And then there's the constant. So for the constant, I'm going to have to combine these two constants, the 64 and the 1, to get me 65. And I am almost there, right? Almost, okay? I need an equal 0 on the right-hand side. So if I need an equal 0, let's just take away 25. What is that, 40? So nothing too hard on the brain. It's just a bunch of algebra, but just don't make mistakes, right? It's so easy when adding and subtracting or multiplying to do some bonehead error. But other than that, it's just foiling and getting everybody on one side. You guys got that. All right, now a little bit tougher than that is the other way. So instead of going from standard to general, going from general to standard, okay? So earlier in the year we did, or in the semester, we did learn the formula for completing the square. So let's just remind ourselves of that, okay? So we'll put formula for completing the square. Okay, so the formula for completing the square, you guys, is 1/2 of b squared. So this is not going to go away. We're going to be using this, quite often throughout the year. We'll get back in conics again in chapter 7. We'll use it again. Okay. All right, group the x terms and the y terms. Okay, so what that means is just basically get them closer together. Right now, this 4x is, separated from the x squared. There's a y squared between them. We don't want that. We want them right near each other. All right. And then the y squared and the 20y need to be near each other. Okay. And I'm going to just follow their steps. I'll usually do this in one step on the next 2 times we do it, but I'm just trying to go by what they say over here on the left. All right, then we're going to move the constant term to the right-hand side, and we're also going to leave a little space after, after the 4x, we'll leave a little space. And after the -20y, we'll leave a little space, okay? Because we're going to add numbers into those blanks, you guys. So we're putting a little space here. Plus blank. I'll do this one in green, I guess. Plus blank. All right, so we're going to go ahead and complete the square. So let's complete the square twice, actually. So we're going to take 1/2 of b and we're going to square it, where b is this -4. So we're going to take 1/2 of -4 and square it. So that's going to be -2, which is going to be +4. Now remember, whatever you do to one side, you have to do to the other side of an equation too to keep it equal. All right, we have to do it again, but this time to the b -20. So 1 for the x and 1 for the y. Well, 1/2 of -20 is -10. -10 squared, that's 100. So we're going to add 100 there, and we're going to add 100 there. Okay. All right, so we're just going to keep on working on getting this guy all cleaned up. So let me write in a little bit. Well, I think we could do this, you guys. So we're going to take this trinomial right here, and we're going to factor it as a perfect square. So you'll remember it's going to be x minus because there is a minus sign here, okay? You remember we had a shortcut, and the shortcut is it's always going to be half this number. And that number actually lies right here, by the way. So 1/2 of -4 is -2. And that makes sense because what's -2 times -2? +4. What's -2 plus -2? -4. So you're essentially just factoring it. You're saying what multiplies to make the last number, but adds up to make the middle number. Instead of having to think about it really hard, we have this shortcut where it works, where we can just always half the middle number every time, okay? So for this next one, 1/2 of -20 is -10. And then you can check that too. -10 times -10 is +100. And -10 plus -10 is -20. So it works out nicely. All righty, I think this comes to 40 if you add everything up on the right-hand side of the equation. Yeah, okay. All right, so we are officially in standard form here. So we should be able to identify the center and the radius, okay? So let's come in here and get the center. Now remember, you're just changing the signs. If it's a -2 here, it's a +2 here. If it's a -10 here, it's a +10 here. Now for the radius, remember the right-hand side of the equation, you guys, this part isn't r, it's r squared. So we know r squared equals 40. But we have to square root both sides. There's no need for a plus or minus here because the radius can't be negative, it's a length. You wouldn't measure a circle and with the tape measure and be like, yep, negative too long. You would just say 2. So I'm not going to put the plus or minus. Now the square root of 40 40 is 4 times 10, right? So it looks like R would be 2 root 10. Or you can just use the prime factorization to 40, right? 4 times 10, 2 times 2, times 5. Doubles on the outside, singles on the inside. So it looks like it's 2 root 10. Okay. All right, we are by no means professionals. Let's get to the point to where we feel really comfortable with these by just doing a few more guys, okay? All right, so we're going to group together the x's, and we're going to leave a little space after it. We're going to group together the y's. We're going to leave a little space after it. And any constant, we're going to move it over to the other side. So it's going to be negative 21 on the other side. All right, we're going to take half of b and square it. So we're going to take half of 10, square it. So that gets us 5 squared. It's 25. Whatever you do to one side of the equation, you must do to the other side, right? So if I put a plus 25 on the left, I need to put a plus 25 on the right. All right, let's try it again. This time to the 4. So oops, we're going to do half of b and square it. So we're going to do half of 4 and square it. Half of 4 is 2. 2 squared is 4. So if we put a plus 4 here, then we got to put a plus 4 there. All right, now each one of these trinomials is going to factor. And we said you just take half of the middle number. Half of the middle number. All right, and it looks like we're going to get 8 over here on the right-hand side. All right, we're ready to say what our center and our radius is, you guys. Well, at least the center. That's going to be fairly easy. Just change those signs. So it's going to be negative 5, negative 2 for the center. And then for the radius, we know r squared is 8. So when we square root that to figure out what 8 is, we know that the square root of 8 would be 4 times 2. That's 8. So it looks like it's going to be 2 root 2. Okay. All righty, you guys. Slowly but surely we're getting there. A lot of pieces to this type of a problem. All good. We should definitely do some fractions, right? Good for the soul. All right. So we're going to group together the x's. And we're going to leave a little space after it. And then we're going to group together the y's. And any constants get moved over to the other side. Okay. All right, so we're going to go ahead and use that formula for completing the square. So we're going to take half of, in this case, 3. So we'll just multiply straight across, you guys. So put a 1 underneath. And if you multiply straight across, you get 3 halves, 3 over 2. You really don't want to go decimals with it because it's a lot harder to square 1.5 than it is to square 3 halves. Okay, or in general, I mean 1.5 times 1.5 is 2.25, but some of them are hard, I think. But I can square 3 easily and I can square 2 easily. That's going to be 9/4. So for once, fractions are better, right? Okay, a lot of you like decimals, I know. All right, so then let's go ahead and do half of the other b and square it. So we are going to do half of negative 12. Negative 12 is negative 6, and negative 6 squared is 36. We do it to that right-hand side also. All right, this trinomial has to get factored, and so does that one. So x minus, well, taking half of 3 halves, that means, or taking half of 3 means dividing it by 2, so putting it over 2. And remember, you can just steal the numbers over here on the right before you square, because you literally already took half of 3, right? So just steal that, half of 3, 3 over 2. Alrighty, and then over here, half of negative 12 is negative 6. Again, you can just steal this number over here. All right. So let's go ahead and let me see. Yeah, I'm going to do these two first. Okay. So if I do those two, the bottom stays the same, you guys, right, on a fraction. So it's over 4. And 149, negative 149 plus 9, that's negative 140. And 4 goes into 140. So let's see, it goes into 14 3 times. I think it's 35, you guys. You can check me with the calculator. Okay. All right. So I'm just going to, bring this guy on down. Okay. So let's go ahead and go for our center. So change the signs. So instead of negative 3/2 positive, instead of negative 6 positive. And our radius we know is going to be, well, r squared is 1. So when we square root both sides, we get r is 1. Okay, so those are our answers for these. And I believe it just said to get it, it didn't say to graph it, I don't think, you guys. Let me make sure. Yeah, it didn't. All right. Okay, so when you're going from general form to standard form, you might not always have a circle. In order for you to have a circle, that r squared that's on the right-hand side of the equation has to be a positive number. Now, it would be problematic if it were a negative number, because we know, let's say we have a negative number over there. Let's say it's negative 64. Well, we know that we would say, okay, r squared equals negative 64, and we would square root. And I think you can see why this would be problematic, right? This would be imaginary. You can't have an imaginary radius, right? So it says right here, if r squared is less than 0, in other words, negative, then the solution set is the empty set. Okay, so that's case 1. So you don't really have a circle there, you guys. All right, now if you have the case where it's not negative, but let's say it's 0 on the other side. Okay, so then you say, okay, r squared equals 0, and you square root, right? And you get that your radius is 0. So what would that mean? You have this circle where 3, -1 is the center, and you go 0 out in every direction. You don't have a radius, so you don't go anywhere out. Well, this will have a solution. It'll have this one point as the solution, right? This single point is the solution. That's all you'll have. So your solution set won't be the empty set. It would be 3, -1 in this case, right? Okay, unlike the other one. And it should be kind of obvious that this one on the left is no solution, because you're squaring something, so it's positive. You're squaring something, so it's positive. And then you're adding those two things together. How could it ever be negative, right? Okay, so nothing will work for this one. On this one, 3, -1 works. Plug 3 in, you get 0. Plug -1 in, you get 0. Add them together, you get 0. Okay, so this is going to be a single point. It'll just be the center. That's it. Okay, so these are what we call degenerate conics. It's not your typical, circle. Points are degenerate conics, lines are degenerate conics. Okay, so we don't really talk about them often. They don't come up often, just simply because they're not really interesting. There's not much to say there. So you won't see a ton of degenerate conics on your homework. All right, you guys. Well, that is it for 2.2. Thanks for joining me, and good luck on the homework.